very conceptually related to our last problem. This question gives me this equilibrium reaction and a Kp value. It then asks, or says, if hydrogen gas were added to the system already at equilibrium, how would the concentration of iodine gas, this thing right here, change? Well, let's take a look. Kp, of course, is going to be equal to the individual pressures of the products, H2, multiplied by each other, multiplied by the pressure of I2, divided by the pressure at equilibrium of Hi squared, because that number goes from being a coefficient to an exponent. And frankly, as I think about it, the Kp value is not actually relevant at all to be able to answer this question. It's asking me that if I add H2 to the system once it's already reached equilibrium, what's going to happen to iodine? So let's imagine that. According to the Chatelier's principle, I've got this thing sitting at equilibrium already. If I start increasing the amount of H2, which direction does it have to move in order to reestablish equilibrium after we've introduced that imbalance? Well, I add a bunch of H2 to the scale. I've now made the right too heavy. So in order to compensate for that, it has to move to the left. In order to move to the left, it has to consume H2 and I2 and recombine them to turn them into Hi. So once again, I've jacked up the amount of H2. In order to compensate for that, it has to move to the left, and it has to take I2 with it. So what's going to happen to the I2 in order to reestablish equilibrium after increasing the amount of H2? Well, yeah, you're right. It's going to have to go down or decrease.